Welcome to Learners Academy. In our last video, we explored polynomials. Specifically, we learned that polynomials are expressions made up of terms connected by addition or subtraction. Each term consists of a number, coefficient, multiplied by a variable raised to a power. If you don't remember the concepts, consider re-watching the first video before continuing. Even though polynomials are straightforward, sometimes they appear more complex than necessary. And in math, what do we do when things seem complicated? We simplify them. In this video, we'll learn how to simplify polynomials. This involves identifying and combining like terms with the same variable and exponent, so that the polynomial becomes simpler. Let's examine a basic polynomial. We don't need to show the coefficients of each term if they are just 1. Also, any number raised to the power of 0 is just 1, so we don't really need to show that either. In this example, we have a term of every degree from 0 up to 4. But there can be polynomials in which certain degree terms are missing, like in this example where we don't have a third degree term, which is perfectly fine. However, a polynomial might also have extra terms, like in this example where the third degree term has been duplicated. Let's analyze more polynomials. This polynomial has no x squared term, which is fine. And this polynomial has just one x squared term, which is fine. But this polynomial has two x squared terms, which is also fine. While this is allowed, it makes the polynomial more complex than necessary. And whenever you have terms like this, terms that have the exact same variable part, they can be combined into a single term. So we should combine the x squared terms. Therefore, 1x squared plus 1x squared makes 2x squared. Easy, right? Okay, what we have just done is combining the like terms. Like terms are those terms which have identical variable parts, meaning they have the same variable and they are raised to the same exponent. And the law says that if we have like terms, we can combine them by adding their coefficients. For example, to better understand, imagine substituting variables with colored balls. Let x cubed be replaced with red ball, x squared with blue ball, and x raised to the power 1 with yellow ball. Then we can represent the polynomial as 2 red balls plus 4 blue balls plus 5 blue balls plus 2 yellow balls. If we want to add 2 red balls and 4 blue balls, we will still get 2 red balls and 4 blue balls. Since they are different color balls, you can't combine them, right? But if we add 4 blue balls and 5 blue balls, we will get 9 blue balls. This means, since different variables represent different things, we can only combine terms with identical variables and exponents. Therefore, it is super important that variable parts of a term have to be exactly the same in order to combine them. If the variable parts are different, like x cubed and x squared, then they represent different things. So we can't group them into a single term the way that we can if the variable parts are the same. So far, we have learned that if two terms in a polynomial have exactly the same variable part, then we call them like terms, and we can combine them into a single term to simplify the polynomial. Now, let's simplify some polynomials step by step. Here we have 4x and 2x. Are they like terms? Yep, the variable part of both terms is the same, which is x. And both the variables are having the same exponent, which is 1. So we can combine them into a single term. We do that by adding the number parts and keeping the variable part the same. 4 plus 2 is 6, so we get the combined term 6x. Next, we have 3x squared and negative 5x squared. Well, the variable part in both is exactly the same, which is x squared. Therefore, they are like terms, and we can combine them. Even if the coefficient of one of the terms is negative, they can be combined as long as their variable part is identical, which is x squared. So these combine to negative 2x squared. Next up, we have 5x plus 5y. Are these like terms? Well, you may notice that both have same coefficients. However, that is not mandatory for combining terms. Moreover, both the terms are first-degree terms, but since the variables are different letters, they are not like terms. That means we can't combine them. Next, we have negative 5xy plus 3yx. At first glance, you might think that the variable parts of these terms are different. After all, xy seems different than yx. But we know that multiplication is commutative, which means order doesn't matter when multiplying two entities. This means x multiplied y is same as y multiplied x. Or xy is same as yx. After rearranging, they look identical too, with same exponents, which is 1 in this case. Now, we can combine the like terms. Negative 5 plus 3 is negative 2. So we end up with the single term minus 2xy. Lastly, we have 3x squared y plus 3y squared x. Here we have to be a bit careful. It may seem an identical case as in the last example, but even if we switch the order, the exponents move with the variables. In the first term, the x is being squared, but in the second term, the y is being squared. Therefore, the variable parts are not the same, thus both the terms are not like terms, and cannot be combined. Now that we have practiced like terms, let us go through some polynomials where we look for any like terms and simplify by combining them. Here's our first example. X squared plus 4x minus 2x plus 8. If we look closely, we can find some terms with same variable parts. Yes, you have figured it out correctly. There are two terms, both having the variable x, so we can combine them. 4x minus 2x would just give us 2x, since 4 minus 2 is 2. So we have simplified a polynomial with 4 terms to 3 terms. X squared plus 2x plus 8. Let's try this one. 14 minus 3x cubed plus 2x minus 6. In this polynomial, we have a third-degree term, a first-degree term, and 2 constant terms. Are those constant terms like terms? Absolutely. They're both just numbers and don't really have a variable part, so we can combine them easily. This term is positive 14, and this term is negative 6. So if you add them together, you end up with positive 8. And as we have studied in the previous video, it's always a good idea to rearrange the polynomial in descending order to keep the things neat and easy. Remember, it's best to think of all terms in a polynomial as being added, but they can have coefficients that are either positive or negative. That's why this negative sign stays here with the 3x cubed term, because it's a negative term. Okay, let's dive into an even more complicated example. 3x squared plus 8 minus 2x plus 4x squared minus 3 plus x. This polynomial has 6 terms, so let's see if any of the terms are like terms that can be combined. Let's rearrange the terms to ease things out while figuring like terms. Okay, so right away you may notice that there are 2 constant terms in this polynomial, positive 8 and negative 3. Combining them into the single constant term gives us positive 5, since 8 minus 3 equals 5. Next, we see that there are also 2 first-degree terms, negative 2x and positive x. Those are like terms, so we can combine them. Negative 2x plus 1x gives us negative x. We also have 2 different second-degree terms that can be combined too. 3x squared plus 4x squared gives us 7x squared. So our polynomial has been simplified from 6 terms to just 3 terms, 7x squared minus x plus 5. That was super interesting, isn't it? Now you know how to simplify polynomials through simple steps. We identify and combine like terms. But watch out for the little tricky polynomials, as they may not be in same order. That means you may need to do some rearranging as you look for terms that you can combine. Look for the pairs and combine them. A helpful strategy is to cross off terms in the original polynomial as you combine them, ensuring that you don't accidentally miss any. Any terms that can't be combined just come down into the simplified polynomial as it is. And lastly, don't forget to treat each of the terms as either positive or negative, depending on the sign right in front of it. With practice, simplifying polynomials will become super easy. As always, thanks for watching Learners Academy, and I'll see you next time with exciting video on mathematics.